Hello everyone. Today we are going to start with the chapter number 3rd of the this chemistry, and this chapter is electrochemistry. We are going to start with the different modules. Let's start with the module number first. So first of all, we are to start with the term electrochemistry. What is electrochemistry? Electrochemistry is defined as a branch of chemistry that deals with the relationship between electrical energy and the chemical changes that takes place in a redox reaction. So such a relation is related to a branch named electrochemistry. So electrochemistry, the branch of chemistry that deals with the relationship between electrical energy and chemical changes that takes place in a redox reaction. Such a reaction, such a concept is called the term electrochemistry. And in electrochemistry, we are to shifts into different portions. So let's start with the portion number first, part number first, and the very basic term is called conductors. So conductor may be defined as the substance which allow the electricity to pass through them. Suppose we are having any metal, we are having electrolytic solutions, all such things are called conductors. So conductors are of different kinds. So conductors, let's start with the first type, that is called metallic conductor. Metallic conductor or electronic conductors. Electronic conductors. So metallic conductors are those conductors in which the conduction is due to the flow of electrons. So such conductors show the conduction due to flow of electrons. Because in every metal there is electrons and their flow will show the conduction. Next thing is no dissociation or decomposition of the metallic conductor occurs. So whenever we are studying about the conduction phenomena of the metal, there is no dissociation or decomposition of such conductors. Next thing is when temperature is increased, the conduction of such conductors, conduction of such conductor that gets decreased, it gets decreased. The decrease in conduction is due to the flow of positively charged kernels. Flow, or we can say vibration. Because with increasing temperature, such kernels will start vibrating. That's why they will retard the motion of the flow of electrons, and they retard motion of electrons. As any metallic lattice has such structure, it has positively charged kernels. These are positively charged kernels, and electrons are moving. The motion of electrons are retarded by flow of these kernels, which are positively charged species. So these are positively charged kernels, and when their motion that gets stopped, the flow of electrons motion gets stopped due to the vibration of these kernels with increasing temperature. So let's study it again. The metallic conductors or the electronic conductors, these are generally metals. For example, we are having iron, aluminium, copper, zinc, etc. Whatsoever these metals may be. So this is called metallic conductor or electronic conductors. Here the conduction is due to flow of electrons. There is no dissociation or decomposition of the metallic conductor that occurs. Next is when temperature is increased, the conduction of such conductor gets decreased. It is the most important portion, that why the conduction gets decreased. Because with increasing temperature, the positively charged species named kernels, they show vibration, and due to their vibration, the flow of electrons gets retarded, gets hindered, gets stopped, gets affected. That's why the conduction gets decreased with increasing temperature. Let's shift to the next term, next type of conductors, and they are called electrolytic conductors. Second type of conductors are called electrolytic conductors. Electrolytic conductors are those conductors which have electrolytes, for example NaCl. Aqueous NaCl gets dissociate in aqueous solution into their ions, Na positive aqueous plus Cl negative aqueous. Here the conduction is due to flow of ions. The conduction is due to the flow of ions, and the flow of ions only occur when there is dissociation or decomposition of the electrolyte in aqueous or molten state. It means the dissociation or decomposition of the electrolyte occur. Next, the conduction increases with increase in temperature, because increasing temperature increase kinetic energy of the ions, and hence flow of ions increase. Flow of ions that gets increased, and hence the conduction gets increases. So let's again discuss about the electrolytic conductors and metallic conductors. These are two different aspects which we have to study. In case of electrolytic conductors, again I am saying, for example NaCl, aqueous condition NaCl, it get dissociate into ions Na positive and Cl negative. The conduction is due to flow of ions. the dissociation or decomposition of the electrolyte that get occur, the conduction increase with increase in temperature, because increase in temperature increase the kinetic energy of the ions, you can say, and flow of ions. Whenever we are talking about the solid state, in case of solid state, the electrolyte do not conduct electricity. I am again repeating, the electrolyte do not conduct electricity in solid state. It is because in solid state it do not get dissociate into its ions. That's why the conduction do not occur in solid state. Now let's shift to the some of the general terms one by one. The first general term is named as resistance. The very first general term that is named as resistance. Resistance is shown by the term R. Resistance can be explained by Ohm's law. Suppose we are having a conductor. This is conductor. And to the ends of conductor, if voltage V is applied, then current I is flown through the wire or the conductor. As according to Ohm's law, V equals to IR, or R resistance equals to V by I. The unit of the resistance will be ohm. It can be shown by this symbol ohm. The next basic term is named as conductance. Conductance is shown by G. It is defined as the ease of flow of electrons through the electrolyte. It is shown by G, and the term G, it is the reciprocal of resistance R, and when we are talking about the unit, it will be equals to ohm inverse, we can say, mho, or the very basic term named Simon, shown by S. So this is about the basic term of this particular aspect. We have discussed about resistance, conductance. The next term is named as specific resistance or resistivity. It is shown by the term rho. As the resistance R, that is directly proportional to length and inversely proportional to area of cross section of the cell of the electrolyte. I am again telling, the resistance is directly proportional to the length and inversely proportional to the area of cross section of the cell of an electrolyte. This proportionality constant, this can be replaced by the term rho into L by A. So rho, that will be equals to R into A by L. This will be the formula for rho. The unit of rho will be, if we find the unit from this particular aspect, we find that R, its unit is ohm, it's a centimeter square divided by centimeter. The unit will be ohm meter, ohm centimeter. So this will be the unit of resistivity. Resistivity can also be equals to 1 by kappa. We shall discuss it later on. And when we define it, then rho will be equals to R when area of cross section of the cell equals to 1 centimeter square and length equals to 1 centimeter. So as per the definition, the resistivity is equal to the resistance when the length of the cell is 1 centimeter and area equals to 1 centimeter square. So we have discussed the three basic terms. Let's explain them again. Resistance shown by R can be explained by Ohm's law and unit comes out to be ohm. Conductance, the ease of flow of electrons through the electrolyte, shown by G, reciprocal of R, and the unit comes out to be Simon. This unit we have to keep in mind. Next is the term specific resistance or resistivity, shown by rho. We have to learn it by this formula, R directly proportional to length by area. This proportionality constant R, it can be replaced by rho. R equals to rho L by A, and find out the value of rho. Rho equals to R into L by A. Unit of R ohm, and area centimeter square, length centimeter. We find ohm centimeter, that is the unit of resistivity. And when we are to explain this resistivity, this will be equal to the resistance when area comes out to 1 centimeter square and length of the cell comes out to be 1 centimeter. So today in the first module we have discussed about these three basic terms. In the module number 2 we shall discuss further the different basic terms named specific conductance, conductivity and molar conductivity, and other aspects in the next module. Thank you for today's lecture. Thank you.